All right, we're back. We're on page 57 of math analysis. We're talking about inverse trig functions. And so far what we've worked out is that we know the functions, right? Sine, cosine, tangent. We know their ranges. So sine and cosine are stuck between -1 and 1. Tangent is just all reals. Then we thought more about it and we decided that the inverse functions, the domain of the inverse, it corresponds to the range of the original function. So we, by default, because we knew the ranges of the trig functions, we therefore knew the domains of the inverse trig functions. So we're calling them arc sine, arc cosine, arc tangent. Could just as easily have been written as sine inverse to get sine inverse of x, cosine inverse. These are interchangeable notations. One of which is easier to type, and you can easily guess which one is easier to type. So the next thing we're going to do, we realized that we had a problem because the trig functions are periodic, and so the trig functions overall, they're not going to have an inverse that's a function because, you know, sine is equal to 1/2 at pi over 6, at 5 pi over 6, but then also every 2 pi around, right? So pi over 6, 13 pi over 6, just keep adding 12 pi over 6. You keep getting coterminal angles, so sine keeps being 1/2. So we're going to fail the horizontal line test like everywhere, an infinite number of times. So what we're going to do is we're going to take the graphs of sine, cosine, tangent and turn them into one-to-one functions. And we will do that by just simply erasing, right? So what I normally do when we do this in class is I play around with the GeoGebra file. It doesn't translate very well to video. So what I did instead, which also may not translate very well to video, is I have hand-drawn our graphs. And I am now going to attempt to create one-to-one functions out of these using literally an eraser. So that's kind of the goal here. So we'll see how it goes. So the first thing we want to do is we want to make a one-to-one function. So a one-to-one function will pass the horizontal line test, right? So if we look at this, I just want to think for 1 second about the unit circle. Like what parts of this correspond to what parts of the unit circle? So on the unit circle, 0 to pi over 2 radians is the first quadrant. So this is really quadrant 1 from the unit circle. And then pi over 2 to pi is quadrant 2. And then it'll be quadrant 3, and then quadrant 4. And we could just keep going and repeating. I mean, I didn't take the graph out that far, but we could do it. If you go backwards, so 0 to negative pi over 2, that's a clockwise rotation. So you start on the x-axis, you go clockwise, that's going to be quadrant 4. So this is actually quadrant 4 of the unit circle. So we always read of the unit circle. This would be quadrant 3, quadrant 2, and then quadrant 1. So this is how it corresponds to the unit circle. So these things that we've currently written, these are unit circle quadrants. They're not the quadrants where the actual curve is falling, because for weird-ish reasons, we care more about the unit circle than we do about the quadrant. I've never, I think, answered a question about where the graph of actual sine is, like what quadrant it's in. I don't know. I mean, I guess you could be asked those questions, but I can't think where I would do it. So we need to make this one-to-one. So what I'm going to do is I'm going to start with a horizontal line. So turn that into a horizontal line for me. All right, so now what I'll do is I'm going to pick it up and just start moving it through the graph, because that's basically how the horizontal line test works. So here, we're hitting the graph. Now, you can see that we're failing the horizontal line test because at pi over 2, I hit the graph, but also at -3 pi over 2, I hit the graph. That's a problem. So what we want to do is we need to make choices. We're going to delete some stuff or erase it, however you want to say it. So what I'm going to do is I'm just going to think, like, where do most things happen in life? Like applications, things like that. They usually happen with everything positive. Like you don't run into a lot of negative lengths and things like that in life. So I think it makes sense to keep quadrant 1. So I'm going to keep quadrant 1, which is where every x and y on the unit circle are positive. I'm going to keep that, which means I'm going to keep this part. So what I need to do to make this function one-to-one is I need to erase everything where I would also be hitting the curve. So for example, once I've decided to keep, so I'm going to keep pi over 2 because it's the end point of quadrant 1. That's the quadrantal that breaks up quadrant 1 from the rest of the quadrants. So I'm keeping that. So, I mean, over here, I kind of need to just start erasing, right? So I want to erase this because everything here is going to make me fail the horizontal line test. And if there were more things, let me just make this eraser bigger. Like, this is probably too big. Probably. We'll find out. So I'm also going to go over here and erase things. Let me get the line out of the way. Get out of the way. There we go. Okay. Now I can just erase like crazy. Gone. Okay. So to the right of the y-axis, this is now 1-to-1 as long as I stay above the x-axis. So I've kind of accomplished my goal. Over here, I need to erase everything above the axis because it's preventing me from having a 1-to-1 function. So I got this. So actually, I can erase this. Gone, right? And why is it gone? It's gone because I need a 1-to-1 function. And if I kept that part, I didn't have that. So let's take our line and do it again. So now if you look at this, 1-to-1, 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 it's 1-to-1 all the way as long as you stay above the x-axis. When you get to the x-axis, you start having a problem. There's actually a lot of places where it currently hits the x-axis, so at negative pi, at 0, at pi, at 2 pi. All of those are a problem. Well, all but one of those is a problem. And then here, we're having like a huge issue, right? So we need to decide what we're going to delete or erase, depending on how you want to say it. It's like I'm using a computer-like device, so I think delete is the right word, but also I'm clearly using the eraser capability of it. I don't know. All right. I think the right thing to do is to create a continuous graph if I can. So like I could save 0 to pi over 2 and I could save, so I just need the whole range, right? So 0 to pi over 2 gives me 0 to 1 in the range. So I could save pi to 3 pi over 2, which gives me the whole bottom of the range. I could save 3 pi over 2 to 2 pi, which also gives me the whole bottom of the range. But like it gives you this really weird discontinuous graph. I don't want that. So what I'm actually going to do, I'm going to save this part of the graph because then I'll just be left with this nice little continuous segment here. And that's what I want. That'll give me a 1-to-1 part of the sine graph where I'm getting the entire range. That's what we need. So let me move this thing out of the way and I'm going to start erasing, right? So we're saving this. So everything else has to go. So if I start erasing here, now you can start seeing, maybe I'll put a solid dot here. We're keeping that. So you can see on that little interval there, sine covers the entire range and it's 1-to-1. And the domain of that little interval there is negative pi over 2 to pi over 2. That's going to be important. Let's keep erasing though. So this has to go because we need a 1-to-1 function. Gotta go. And there. So if you look at what's left over, what we really have here, also I should say I added this page in because I wasn't going to be able to do the GeoGebra thing. So this is like an extra page in the notes. So maybe if you were just, it's a little late to be telling you this, but if you want to use a separate sheet of paper, that'd be kind of a good thing to do. So here's our 1-to-1 sine. So I'm going to write down it's 1-to-1. And the domain is negative pi over 2 to pi over 2. So what does that mean? That means this covers the entire range. So I'm going to use this to create my inverse function, right? I'm going to switch x and y, which means since the range of this is negative 1-to-1, the domain of arcsine will be negative 1-to-1. Since the domain of this graph that we're looking at right here, this is not the graph of arcsine. The domain of this graph is negative pi over 2 to pi over 2. The range of arcsine is going to be negative pi over 2 to pi over 2. This is our one. This is a really important graph. I think of this graph more often than I think of the graph of arcs. I almost never think of the graph of arcsine, to be honest. The other thing that's really important is if you think about what part of the unit circle you're getting. So let me just draw a unit circle here. That's not a circle, like even remotely. Give me a circle. Okay, so if I draw a circle here, the only parts that I'm left with are actually from negative pi over 2 to pi over 2. So I'm going to trace this. This is actually how I created the graphs of sine and cosine also. I imported them from GeoGebra and then I tried to trace them, and it was not great. So here, this is the only part of the unit circle that you have left. So we've limited sine, we've made it 1 to 1, and then we are left with only little parts of the unit circle. So the only angles you'll ever be saying as answers to the arcsine of something, the only angles you'll ever find yourself saying are from negative pi over 2 to pi over 2. And so you know a lot of them, right? I mean, like inverse sine of 1/2, got to be pi over 6. It's the only angle between negative pi over 2 and pi over 2 that has a sine of 1/2. You know, inverse sine of root 2 over 2. It's going to have to be pi over 4 because it's the only angle satisfying that. Inverse sine of negative root 2 over 2. So negative root 2 over 2, it's going to put you down here, right? So here, you want to say probably 7 pi over 4, but you can't because you need the angle to be between negative pi over 2 and 0. So instead, you'll say negative pi over 4. So this is what we're going to go with. So I think what I'll do is cut this video here, come back in the next one, and do cosine and probably tangent in the same one. So this one took a little more explaining, I think, because you have to really get the concept. Once you get the concept, I think we can go a little quicker. So I'll see you in the next video where we're going to do cosine, make it 1 to 1, tangent, make it 1 to 1, and then maybe press on, but maybe also not. So I don't know. I'll see you there.